All right, so our next lesson is area of regular polygons. And just for your reference, this is actually topic 13, section 3. So if you wanted to look this up more in your textbook, you can do so by looking at that. So we're going to start off with some vocabulary for this section. We've already gone over a lot of this. One of them is a new word. So just to let you know, we're going to go over what it means for a polygon to be regular. A new word that we're going to learn is apothem or apothem. It could be pronounced either way. And we're going to use the word radius. It is the same thing as the one type of radius we've used before. However, it's the first time we use it with something that's not a circle. So anyway, a regular polygon is a polygon that is equilateral and equiangular, meaning all the sides are the same and all the angles are the same. An apothem is the line segment that goes from the center of that polygon to the midpoint of one of its sides. And the radius is the line segment that goes from the center to a vertex. So notice that in the image, the apothem is in blue. It goes from the center to the middle of a side, but the radius goes from the center to a vertex of one of those sides. So here we're going to find the area of a hexagon, a regular hexagon to be more specific. Here is my apothem, 8 centimeters, and one of my sides is 10 centimeters. Notice that I'm drawing a bunch of radii. That's the plural of radius because they go from the center to an edge. And I want to know how many degrees are within each of these sections. So what I did was I took 360 degrees because that's the number of degrees that's in a circle. And I divided it by 6 because since there are 6 sides, I'm able to make 6 triangles with all of those radii. So that means each section has 60 degrees. Now for one of them though, one of the sections, I'm going to cut it in half to show you how there are multiple apothems. So I already have one of them, and that's measured as 8 centimeters. But you can draw others throughout the same shape. So I drew another one. They always come out to be perpendicular to a side. And since I knew that those central angles were each 60 degrees, and it was going to be cut in half by that apothem, it made 2 30-degree angles. And when you have your warm-up, the next time we cover this lesson in class, you're going to have to be able to figure out the angles like this. So make sure you write notes of it. When you do this, notice that it makes a right triangle. There's 2 right triangles there at the bottom. So not only did we determine that these angles are 30, but the other one must be 60 because this makes a 30, 60, 90 triangle. I did that because I knew a triangle has to add up to 180, subtracted the 90 of the right angle, the 30 degrees from the top, and I'm left with 60 degrees that must be on the bottom corners. So there's a formula that we're going to use for a regular polygon. And this is for all regular polygons. Area is 1/2 A, which stands for apothem, times P, which stands for perimeter. So I know my apothem is 8, but okay, so I still need my perimeter. And all I know is that one side length is 10 centimeters, but because this is a regular shape, all the sides must be 10. So if all 6 sides are 10 centimeters, then my total perimeter is 60 centimeters. Now that I do that, I could work this out. 1/2 times 8 times 60 brings us to 240, and those are square centimeters. So notice that now Even though all of our units before were in centimeters, I've changed it to square centimeters because we're working with area. But now I want to talk about where that formula came from and why it works, because we've never used this formula before. So here I have a pentagon inscribed in a circle, and it is a regular pentagon, or at least I tried to make it one. And I've already taken the liberty of drawing in blue my 5 radii, as well as 1 apothem in red. Now there is more than one apothem. There's actually 5 that can go around it. But really I only need 1. So I do want you to get in the habit of, whenever you're working on these problems, automatically drawing all your radii and at least 1 apothem. So my apothem is 7 meters, and I've also highlighted 1 side length in red, 10.2 meters. So rather than actually use the formula, I'm actually going to start with the formula for area of a triangle. The area of a triangle is 1/2 base times height. So I can bring down my 1/2. I have to think about what the base is. And my base is, let's see. Well, it's 10.2 because it's the same as the side length. So I can see that all the way around is 10.2, and even though they called it the base, it's a side length. Next, the height of the triangle, of that one triangle at the bottom, is 7. And notice that even though it's the height of the triangle, it's the apothem of my regular polygon. That brings us to a value of 35.7. But I'm not done yet. That's only one triangle. Since I want to know the area of the entire shape, I can multiply that by 5, because that's the number of triangles that I have in this pentagon, to get my final answer of 178.5 meters squared. So I did find an answer already. And notice that I found the answer without using the formula that we were given. But I'm doing this to show you where this formula came from. So immediately I can see where the 1/2 came from, because 1/2 is also in the formula for a triangle. So I did use that 1/2. It has to be part of my formula. The rest of the stuff, well, instead of using height, we used apothem, but that was technically the same thing. So that one was just interchangeable. I just replaced the letter H with the letter A. But perimeter, where did they get perimeter from? Well, what we did use was the side length, but then at the very end, we took that side length and we multiplied it by 5, because that's the number of triangles that we have. So if you really think about it, if you take the base of one of those triangles, or side length, and multiply it by the number of triangles, or the number of sides, what you really just found was perimeter. So that's the reason that instead they just put P instead of telling you multiply it by side length times number of sides. It just made more sense to already write it as perimeter. So that's where the formula came from. That's where it works. But of course, if you find it easier to just figure out one triangle and multiply it by the number of triangles, that's okay. You're going to end up with the same answer, just to let you know. All right, so what's next? Well, this time we're going to practice finding the area of a regular triangle. You may find yourself wondering, why would I use this formula when there's already a formula for the area of a triangle? Well, in this problem, it just so happens that all we're given is 9 feet, and that's one side length. So, although I would know my base, I wouldn't know the height. And of course, we're just getting practice. So we're going to start with this. Again, the first thing that I always do is to draw my radii and at least one apothem or apothem. So that is always the first step, and I've already done that. Next, you're going to want to determine the angle measure for each of those triangles. In this case, I know we always start with 360. I had 3 radii forming 3 triangles. So divided by 3, I see that each one is 120 degrees. But if I want to find the angle measures for the remaining ones on bottom where it was cut in half by the apothem, I do have to divide that by 2 to see that it ends up forming 60-degree angles. If I just focus in on one of those angles, or one of those triangles, the top one is 60, I know for sure I have a right angle of 90, which means that the remaining angle must be 30. And we actually do this because it's going to help us find our answer later on. The next step would be to write out the formula and determine what information I know and the information that I need to know. So knows and needs to know. Well, my formula I know is A equals 1/2 apothem times perimeter. The 1/2 stays there. And I don't know my apothem, so it's just going to have to stay blank for now. That's one of my needs to knows. And I don't really know perimeter, but I can find it out. Because I know that one side length is 9. And because this is a regular triangle, all side lengths are the same. So 9 times 3 gives me a perimeter of 27, and I can fill that in. So at this point, I'm almost done with the problem. I just need to figure out what my apothem is in order to plug it in and actually compute the entire area. So that's what we'll do next. So, because I know that each side is 9 feet, and I know that my apothem cuts that bottom base in half, each half is 4.5 feet. And I'm also going to use that to help me find my apothem. Oh, actually, I do that on the next slide, so let's go there. So I'm redrawing, kind of zooming into that one triangle at the bottom. And again, it's a 30, 60, 90 triangle, which is a special right triangle. I bet you guys thought you were done with these, but nope. The special right triangles you'll use not only in geometry, but in pre-calculus, calculus, etc. So what do we know about this special right triangle? Well, what's special about a 30, 60, 90 triangle is that we could label its sides in a specific way. Across from the 30-degree angle, we can label that x. The hypotenuse is 2x, and then the remaining side, opposite the 60-degree angle, is square root of 3x. How this will help us? Well, my apothem, the value I need to know, is right here. So if I can use this bottom segment to find out what that apothem is, then I could finish up the problem. So right now I have that 4.5 is equal to square root of 3x. To get x alone, I could just divide both sides by square root of 3. And I see that x, or my apothem A, since they're the same value, is 4.5 divided by square root of 3. I could, if I wanted, put this in the calculator and see what it is, but since I don't have a calculator nearby, that's actually how I'm going to leave it for now. So now I can go back to my previous screen, and I can plug in what I know from my apothem. I know it's 4.5 over square root of 3. So I actually have to calculate this. And when you do so, you'll see that it ends up being 35.0740, and it continues. But here I'm actually going to round to the nearest tenth, which on your assignment is what you'll be doing. So I just put all of that together in the calculator, and it's approximately 35.1 feet squared. And that is your final answer for this problem. Before we continue, please make sure that you actually wrote down those steps. And we're going to do one more practice problem before we finish. Okay, so the last problem that we're doing is the area of a regular quadrilateral. But a regular quadrilateral is just another word for a square, since it means all sides are the same. All I know is that, let me go back a little bit. I have a radius there of 12 inches. And when you first look at the problem, this is what it would look like. But of course, my first step is to draw my radii and apothem. So that's what I did in blue. And then in red is my apothem. Next step is to determine all my angle measures. So 360 divided by 4 means each one is 90 degrees. Or you can put the little box. But I had to divide that by 2 in order to figure out the measures of that smaller triangles on the bottom. So divided by 2, we see that each one is 45 degrees, creating a 45, 45, 90 triangle. We're definitely going to use that again in the near future. Notice that that's another of the special right triangles. So we start next by writing out the formula, figuring out what I know and what I need to know. My area is 1/2 apothem times perimeter. The 1/2 comes down. Don't know my apothem, so I'm going to have to figure that out. And as a matter of fact, I don't know my perimeter either. So I'm looking for both of those things, but I can figure it out using that special right triangle I talked about. So I'm going to zoom in on that 45, 45, 90 triangle. I know my hypotenuse is 12 inches. And that's all I know. So all I can do is really start labeling side lengths. Well, I know in a 45, 45, 90 triangle that the two legs each have a value of x, and that the hypotenuse has a value of square root of 2x. So I'm going to use that information to figure out my apothem and perimeter. So if I know that 12 is square root of 2x, I can divide by square root of 2 on both sides and see that x is 12 divided by square root of 2, which that's the same x for both of the legs. So just a heads up, that's both of those x's. Well, one of those x's, the red one, or the side length that's red, is my apothem. So I just figured that one out. I could go ahead and plug that in already. Still need to find my perimeter. It's very tempting to get that bottom number we figured out and plug it in. But we just figured out one portion of the entire perimeter. So we still have to find what the whole perimeter is. The one portion that we figured out there is highlighted in orange with a little 1 by it. And notice that each side has 2 of those pieces. So as we keep going around the shape, we see that there's another 2, another 2, and another 2. So in total, there are 8 of those pieces that we found. So I could take my value for x, multiply it by 8, and find that my entire perimeter is 96 divided by square root of 2. Again, no, it's a weird number. You can put it in the calculator if you want, but I just left it like that for now to keep an exact answer. When I multiply all of this together, I multiply my numerators and denominators first, but you didn't have to do that. But it comes out to 288 square inches. And that is the entire area. Yes, I know, I'm going to hear from a lot of you. Why didn't you just multiply base times height once you found out what one side was? But the purpose of this lesson is to find area of this regular quadrilateral or square using this specific method. So that's the reason we're teaching it this way, and we expect you to work it out this way, even if there may be easier ways to work it out. So to finish, here's a lesson recap. So first of all, the formula for the area of regular polygons is A equals 1/2 apothem times perimeter. We're going to be using that a lot in the next class. In case you don't know your apothem or perimeter in the problem, special right triangles will come in handy. So that's number 2 that you see there. We have 2 special right triangles. One is the 30, 60, 90, shown right underneath. and the other is the 45, 45, 90. In case you don't remember what these look like, you're going to want to write them down so you could reference them, reference your notes during class. And lastly, I think most of you know this already, but just in case, units will always be squared because we're working with area. So you'll see that in either two ways. For example, you might see centimeters with a little square on it, or you might see SQ, which stands for square, and then CM. So either one is okay, as long as you first of all remember your units and remember that they're squared either with the exponent or with the SQ up front. All right, so that's the entire lesson. If you have any questions, please make sure that you ask at the beginning of class or throughout our lesson.